Good morning, welcome to week 3. I'm Dr. Ellie Jameson and we're going to be doing about colour and chromatography today. So what is colour and why is it important to us? So colour comes from the light that we can see, so white light comes from sunlight, and then this can be split into lots of different colours. So if you see something in the sky like a rainbow, this is the white light being split into all of its different colours. So get all these different colours of the rainbow, all from white light. So it's the sunlight passing through the water droplets in the rain that split it into these different colours. So we can see colour with our eyes, and it's helpful to us for different clues and ideas of what's going on in the world around us. So our eyes can only see 3 colours. So with our eyes, we can only see red, green, and blue. And all the other colours that we can see around us are just different mixes of these red, green and blue, going to make the pinks and yellows and all the different colours around us. So colour is important for humans. So first of all, when we used to just hunt and gather all our food, it was help us to spot fruit and trees and things like this, because fruit could be red or yellow and that would stand out nicely against the green of the leaves. So it would help us to find food. And black, the colour black, isn't really a colour, it's just a lack of any other light. But in pens and different things around us, we use different colours mixed together to make the colour black as different colours. So light and colour are important to us. Light helps us see things, but in nature and in the animal world, light can give signals to other creatures. So things like snakes and frogs, which are poisonous, might be bright red or different colours, and they might signal, so wasps and bees might signal to animals that I can sting by having yellow and black stripes. But also things can be attractive, so come over here, try me, eat this fruit, to spread their seeds. And flowers also do it to attract bees, so they have different bright colours, especially blues and things, which attract bees in, because they want the bee to go from that flower onto the next flower and pollinate them, so the flowers can make more seeds and grow more plants. And also green, the colour in plants and things, comes from something called chlorophyll, which helps the plants turn sunlight into energy. So if you've ever fallen over in the grass and you've got a green mark on you, that's from the chlorophyll, that dye in the plants coming out and staining your clothes. So colours are really helpful for people as well. So we like to be bright and colourful, makes us feel happy, helps to attract people to buy things, makes you more easy to be seen. So if you're riding on a bike, you might want to wear really bright, colourful colours like bright yellows, fluorescent colours to be seen on the road. And we also use colours as signals. So in traffic lights, we use red, amber and green to signal the cars to stop and go. We also use colours to colour electricity cables as well, so we know which are the dangerous wires to touch and how you have to wire things to make electrical devices work. So we use colours in all sorts of different ways. We also use it to identify ourselves, like in a uniform. Like at St John's School, they all wear greens, that know they're all from the same school. So it helps to identify things as well. So what gives things colours? Well, we like to give things colours using dyes. That's something taken from plants and animals, or an artificial dye, which can stain them and give them colours. So to make fabrics coloured, then we put them in different coloured dyes and then let it dry and fix into the fabric, and this gives things dyes. We also use different mixes of dyes to make things like felt tip pens. So black, like I was saying, it's not really a colour, but what's interesting in pens is that we use lots of different colours to mix together to make a black colour. So what we've been doing today is trying to look at different colours in the felt tip pens using something called chromatography. Now chromatography, what we're doing is we're drawing things on strips of this is just plain printer paper that we're using. We're putting some felt tip pen near the bottom of them, about a finger space from the bottom. We're putting some blobs of pen, as much pen as you can get on. So we're doing some rainbows, we're doing it with black pens as well. So we've got lots of different types of black pen, because every type of different black pen is made up of some different dyes and colours. So we've done those ones, and then we've just got some really different coloured ones. We tried doing pictures and rainbows and writing words on some of our piece of paper. and seeing how they split. And we've also been using gel pens and seeing if they split in the same way, and fluorescent markers to see how all these different pens split out into their colours. So to do the chromatography, we take our strip of paper and we put our marks at the bottom, so our felt tip pens, and then we take a glass with a little bit of water in the bottom. What we want to do, we want to put our strip of paper in, so that the bottom of the paper is in the water, but the felt tip pen stays just above the water. And then what will happen over the course of the next 5 to 10 minutes is the water will slowly be sucked up through the paper, and with it, we might start to see the colours moving. So these are some that we did before. So this was the black one, so we took the black pen and we put it in the water, and then after about 10 minutes, we got the colours starting to separate out here. So we can take a close look at that one. I'll put the new black one in here. And then we'll take a look at this one. So from the black pen, you can see that as the water has moved up through the paper, so the water gets wicked up by the paper through a process called capillary action. So the water just moves from one tiny little gap in the paper up to the next and slowly moves up against the force of gravity. And when it moves up, if the inks in the pens that we've used are water soluble, these will separate out and you'll be able to start to see all the different colours which made up those black colours. And this one isn't very water soluble, we can see down the bottom, but all the rest, so the B, L, A and C had blacks in which were water soluble, and these start to separate out. So some bits move with the front of the water because they're the smaller dyes, they move fastest up the paper. So that was the blues up here. And then we get the yellows and the purples, and the pinks seem to start moving a bit slower. So there's lots of different colours and different types of pens, different types of black pens made by different companies will have different mixes of these colours. So we'll be able to see them separating out over time. And we can see this is rainbow one. So this one again is different colours, and even inside the pinks and the purples and blues and greens, you can see that we get some separation out of different colours were inside those pens as well. And then this one was up with the highlighters. So with the highlighters, we noticed that the pink highlighter didn't really move. So that one stayed at the bottom. And I've also found that this one doesn't come off our table very well easily either, because it's not soluble in the water that we're using. Because the water works as a solvent and that makes the dyes move up. But these ones, which don't move, aren't soluble in water. So they might need something like alcohol or nail varnish remover to get them moving up the paper. But the ones which did move better, so the blues over here and the yellows, move better. And this one over here was purple. So this one has some of the blue in it, and it has a different pink from here, but also it has this dark purpley bit at the bottom which hasn't really moved. But the yellow, the green and the blue have all moved really fast from the highlighters. So different pens do different things, and if you draw different pictures, and if you draw some parts of your picture in gel pens, the gel pens, so that's the outline of our cat here. So the gel pen hasn't really moved, but the felt tip pens have moved. So bits of the mouth, the whiskers and the ears were coloured in felt tip pens, and those have moved, but the gel pen that we did the outline in hasn't moved. So you can maybe draw a picture and make the type of face that you've drawn on the picture change as it goes. Here's again, there's another little picture that my daughter's done in gel pen, and then the felt tip pen, she drew some little rainbows on its face, and those have moved. And then my other daughter's drawn a smiley face in yellow fluorescent gel pen, and then drawn with black ink the eyes and the mouth on, and those eyes and mouth have started to separate out into the different dyes, while the gel pen stayed at the bottom. So yeah, we've been writing everyone's name in pen, and then putting this in the water, and that one moves up. And it's again the different highlighters. So the pink again hasn't moved to the highlighters, but some of the others have. And then this one was a rainbow drawn with the highlighters, so the pink stayed at the bottom and all the other colours have taken off. And then with this gel pen rainbow, only one type of gel pen has moved out of that, and all the rest have stayed still. So that's all our bits of chromatography, and we've got different ones. We've got fire, so you see how the yellows start at the bottom, but they've actually moved and caught up with the reds now. We've done spotty writing, and that's all mixed together in a big blob now. Done lots of different things. And then we tried doing lines underneath each other. And then these ones look quite exciting. Now this one looks more like fire than the fire one does now. Just lines at the bottom. So we've been doing those, but also what I've been looking at is taking some leaves from the garden and seeing if we can get the colours from those leaves to move. So this was rosemary. So I took some rosemary leaves, I squashed it up in a pestle and mortar, but you can just cut up with scissors and use a spoon to squash it, and then mixed it in with a bit of alcohol. Something from the back of the cupboard's good, something that nobody wants to drink, and then stood the paper in this, and then you can see the line of some of the colours from that start to move up through the paper, and other bits are too big and gritty and they haven't moved anywhere. These are some other leaves. So these ones were quite nicely coloured leaves. So we crushed those up, so they've got purples in the middle, so they're kind of pale and white in the back. And then it's quite difficult to see on here, but these are quite delicate colours that have come out of this leaf. So you can see some yellows and some reds, and they're moving at different speeds through that paper. And then the one which is best was something that I found at the back of our cupboards. We've got some hibiscus leaves for making tea from. So these are petals, sorry, not leaves. So we've got some coloured flowers, and then these ones, I've just put these in hot water, and these ones have started to separate out really nicely. So you can see a really bright pink and a purple there starting to move up through that paper as well. So you can see what different dyes are in natural things. So anything you can think of, if you can put it in some water and make the colour come out, then you can try and get it to move up through some paper. So what works a bit better with the leaves, which we didn't have, is if you've got any filter paper, so coffee filter or something like that, you can put that in instead of the print paper. You can also try that with your felt tip pens. And because that's got bigger holes in that paper, the dyes, when you put them in water, will start to move up much faster, and you'll get bigger bits of the dye coming out as well. So you might get more separation and see more colours with those ones. So you'll get lots of different colours coming out of there. And then what we're going to do next is sweets as well can have colours on the outside of them. So one nice sweet to try, we're going to try Skittles. So we've put some Skittles on a white plate, and we've started to spread them out, a little rainbow on our plate. And what we're going to do, we're going to add some hot water into there. So I've boiled the kettle recently. So put some hot water and get a grown-up to boil the kettle and make sure it isn't too hot. So it just needs to be quite warm, not boiling still when it goes on. So we've arranged our sweets on a white plate, it's best to see this, and then we pour the hot water into our sweets and then see what happens to the colours of the outsides of the sweets. So we can see that as the water hits them, it starts to dissolve the coloured dye on the outside of the sweets and some of the sugar, and then this moves through the water. So we're not using paper at all with this, we're just getting the water to move it. And then the dyes move quite fast through the water on this one. And you get a beautiful colour wheel coming out from your sweets. So you can try putting them on different shape plates, maybe try them in squares, or put lots of different colours, one batch of colours together, so put all the purple ones together and see what kind of interesting shapes you can do. But they have all these nice